Okay, let's talk about correlation and causality. Everything we do in the next two lessons will be done on the calculator. Okay? Everything. It will be done on the calculator using built-in formulas and functions. You won't have to do any long, hard calculations. So be prepared for that. Okay, so let's talk about correlation and causality. There is a difference between the two words. Correlation comes from relationship. Co indicates that there's two involved in the relationship. So basically it's two sets of data that are related. Okay? Causation would indicate that one of the data values causes something to happen to the other one, which may or may not be true. You can have correlation with no actual causation. Correlation basically measures the relationship between two variables. It calls those variables the explanatory variable, which you would normally think of as X. It's what you're free to choose a value and plug it into an equation or what the relationship is, and it'll tell you what Y should be. So Y is called the response or the dependent variable. Dependent because Y's value depends on what X that you're looking at. And we make a graph of that that helps us determine correlation and causality by making what's called a scatter plot. It's a graph that represents the two variables. And again, we're not going to, we can make it in Excel, but in this particular case, we'll probably do these on the calculator. So this is what's called a scatter plot. If you're a farmer, do you think there's any kind of relationship between the amount of rain you get and the number of, or the amount of cucumbers that you'll harvest?
Yes.
Oh yeah. If you get more rain, you're probably going to get more cucumbers up to a point, right?
Yeah.
Because after a while, if it rains too much, then your cucumbers are going to rot. But if it doesn't rain enough, they're never going to actually get enough blossoms. They're not going to be able to grow. They're not going to make cucumbers. That's what this graph shows. Now, it doesn't show you what happens after 100 millimeters of precipitation, because what happens after 100 millimeters may be a whole lot different from what happened up to that time, because at that point you may hit that sweet spot where, hey, this is the perfect amount of rain, and then, oh wait, this is too much rain, and your harvest starts dropping off. So the way this graph works is precipitation is measured in millimeters, and it's on the what we think of as the x-axis, and then your cucumber yield in kilograms. I'm not quite sure what that is. I think that might be a typo, because it should be kilograms cubed, not squared. But that's a measurement of the cucumber yield. They could measure it by the number of cucumbers, they can measure it by the weight of the cucumbers, they can measure it by the actual amount of money they made off the cucumbers. They can do it any way they want to. But this is the explanatory variable. Does it make sense to you that precipitation would explain the amount of cucumbers you harvest. Yeah. In this particular case, can we infer that the precipitation causes a change in the amount of cucumbers? Yeah. Okay? Is this a strong relationship? Now see, this gets into judgment. Okay, this relationship might be a linear kind of relationship, even though you're looking at that and saying, I do not see any lines there, that's just a bunch of little paint splatters. But the paint splatters actually are in kind of a tight band. You know, they're not just all over the graph. They actually kind of rise as it goes from the bottom left corner to the upper right corner. Those dots tend to follow a pattern of sorts. This is a graph of grade point average and the number of hours that you play video games. What's going on? Starts out high, which means you spend a lot of time playing video games. What are we missing to be able to do any interpretation here? I just talked to you about misleading graphs. Yeah, we're not, is this going from A to F, or is it going from 0 to 4 or F to A? Which way is the grade point average going? We don't know. Let's suppose the grade point average starts out that this is 0 and this is a 4.0. If we look at it that way, what is the relationship between the number of hours you play video games and your grade point average? It's negative. Okay? So basically this says the people that are making the highest grades play the fewest video games. And the people that make the lowest grades play the most video games. Now there's a little variation here because look, you've got one person that did more than anybody else on the video games and has a very low GPA. But this person, there's people that made better grades that, you know, this person played less. Those are called outliers. This pattern, this one and this one are called outliers to that pattern. Somehow they didn't fit. This person has a relatively high GPA, but they play a lot of video games. Okay? Not as much as the, you know, my real gonna have arthritis in his thumbs not long from now. Would you say that having a higher GPA causes you to play less video games? No. Why not?
Video games will control your grade.
Yeah, what controls your grade better than video games? You do. The amount of time you spend on your homework, how well you understand the topic that you're studying. There's other variables. Does video games have anything to do with GPA?
No.
Not really. Not that you could prove a cause.
Not
Now-
unless you let it.
Yeah, unless you let it.
It's not really the video game itself. It's you letting the video game get in the way.
It's you playing the video game instead of doing your homework.
Yeah,
Right?
we also,
It's time management.
It is time
we
management.
also don't see ranges, or like, percentages of time spent overall in the day, so maybe that.
Yeah, we don't have a scale. There again, that's the problem with this. There's no scale.
Right.
We have no idea if this is 10 minutes or 10 hours. Okay? The other thing that's interesting to me, this is inferring that your GPA explains how much you play a video game. But wouldn't it maybe, if you were trying to really investigate that, wouldn't you want to put GPA on this axis and put the video games on the bottom? Does that make the graph different?
Yeah. Yeah. it was-
It'll make it look different, but would it show the same information?
Mhm.
Yeah,
That'd be easier to read too.
probably would be easier to read. It'd be easier to read if you had a scale.
Yeah, that's good.
Okay, let's assume that the bottom axis is the average amount of time spent watching TV in a week, and the size of the television is your response variable. Just because you have a bigger television, does that mean you watch television more? No. Just because you have a little bitty television, does that mean you watch less? No, I mean, my 6-year-old granddaughter, Nana, can I have your cell phone? I want to watch videos. I'm sitting there saying, you can't see anything. So, does there appear to be any relationship between those two variables? No. This is called a volume and power scatter plot. I don't like this graph either for the simple fact that I don't know what it's measuring. You know, volume of what? Power measured in what? But notice here there is a pattern going on. This is a pattern. I want you to know that there are patterns. This pattern is not linear. Okay? It doesn't come down a steady amount. It's not that there's no relationship between whatever these two variables are. There is a relationship, but it isn't really a straight line relationship. This is kind of distorted on this end. So when I'm looking at that, I want to be careful and think about what that scatter plot looks like before I try to infer that the more volume you got, the less power you get. Now, one way I could think of this is if this is the volume of water going through a dam, and if this is the power coming out of that dam, it's generating electricity, it's saying that when there's,
Might be the opposite.
it may be the opposite.
Might be like a fan pushing volume of air.
Okay, it could be. And there again, it would help if we knew what the graph was a picture of. So here's a nice, properly labeled graph. This is a scatter plot. This is made in Excel. This shows the pattern of dots going downhill. Which one of these two is the explanatory variable, the hours of training or the number of accidents? Which is the explanatory? Hours of training, because it's on the, what we think of as the x-axis. So we're going to take that to be that it explains the number of hours you get in training will explain how many accidents that you have. Okay? So explanatory is hours of training, response is the number of accidents. As the hours of training increases, what happens to the number of accidents? It dwindles, they decrease, okay? So as our explanatory variable increased, our response decreased. And that has a negative or a downhill trend in that pattern of dots that we can see that tells us that. This shows your math SAT scores, and on the vertical axis it has GPA, which is the explanatory variable. No, the explanatory, remember, explanatory, look up X and explanatory.
Math, the SAT then.
The math SATs, right? And then the GPA is the response variable. What happens as your math SAT score goes up, for the most part? What happens to GPA?
Goes up.
It also goes up. Now, does having a high SAT score cause your GPA to go up? No. There again, you gotta think that, you know, it isn't necessarily cause and effect. There's a relationship, but it isn't necessarily cause and effect. Notice here we have something called an outlier again. This person has a relatively low math SAT. They have a high GPA. What that means is that person either drew patterns and bunny rabbits and stuff when he bubbled in his SAT form, which I actually know somebody that did that. He took his ACT after the big homecoming football game the night before, and he was so trashed by the time he got there that he just bubbled in. You know, he made little bunny rabbit ears and stars and made patterns out of the dots on his SAT. And oddly enough, did really well. Yes, I agree, because I took the test the same day he did, and he made higher than I did, and I worked. Okay. Explanatory and response. This is height versus IQ, and height is on the x-axis.
Explanatory.
Well, we would assume because it's on the x-axis, height would be explanatory, but does height explain your IQ score? I don't think so.
Cool if it
Hmm?
did. So that'd be cool if it did.
No, because I'm vertically challenged.
But I have a lot of confidence.
I bet Shaquille O'Neal would like that thought factor.
But your IQ doesn't explain your height, though, does it?
No, and your IQ doesn't explain your height either.
So,
So basically, you could call those two, you could call it the response and explanatory variable, but the thing is, there's no relationship here. There's none, no relationship whatsoever. And the dots show you there's no relationship because they don't form any kind of a real pattern.
so are we gonna be asked a question like that on the test?
One of the things that you might be asked is, you know, here's a scatter plot. Does there appear to be a correlation? Or, you know, I might do multiple choice. Here's a scatter plot. There is a relationship between this and this. There is not a relationship. This explains that, this explains that. And tell you, you know, mark the ones that are true.
Okay, so this one we would just put no relationship?
Yeah, there's no relationship. I don't see any relationship whatsoever here.
So when there's a scatter plot like this, there are no relationships. It's neither causation or correlation.
No, no correlation and no causation. Now, the thing that you need to take into account, and the reason I keep saying, you know, you can have correlation, you can have causation, but you don't necessarily get causation from correlation. Correlations can exist due totally to coincidence. It can just be some random reason. And I'll give you a good example of that. If you follow the Dow Jones Industrial for as long back as the Dow Jones goes, and you also follow women's fashion trends for as far back as the Dow goes, the Dow Jones Industrial seems to rise and fall in connection with women's skirts. Stock market prices were really pretty high in the mid to late 60s, and women's skirts were pretty short. Okay, then you get into the 80s and women's skirts have gone back to the, I think they call them midi skirts, mid-calf, and stock average was going down, our economy was tanking. Okay? Is there a relationship between the Dow Jones Industrial and women's skirts? No, because if we wanted to fix the economy, we'd all be running around with the shortest skirt we could get by with, which might not be a good thing. Okay? So, you know, yeah, that won't work. So, yeah, that happens to be a coincidence, okay? That those two things happen that way. They can have a common underlying cause, which still might not imply causality between one and the other. For example, your salary and people's salaries and people's ages tend to increase. I mean, you don't get younger, you get older. And for the most part, as people get older, their salary does increase. But does getting older mean that you can have an increased salary? No. Just because you got your birthday doesn't mean you get a raise, okay? Unfortunately, that'd be great. But no, that doesn't work. And yet, they both do increase as time passes. And there's your common cause. Time passes causes your birthday to pass. It means you had another year to your age. And as time passes, salaries do increase, but it isn't because you have a birthday.
Inflation.
It could be inflation, it could be that you got more training, it could be you changed jobs, it could be you went to school and got a different career entirely. There's lots of things that can go on. It could be because your dad owns a company, you know. And then there is a direct cause. Okay, there are places where there are direct causes. For example, if you go to Johnson City Medical Center or any other hospital and you collect birth weights and birth lengths of newborn babies, longer babies weigh more. You know, if you got a baby that was only, I think my grandson was 17 inches long because he was a preemie. He only weighed 4 pounds. So yeah, you know, he was really short and really wasn't very heavy. Whereas my cousin was 24 inches long and weighed 13 pounds when he was born. Yeah, it was a big baby.
I hate to have to have that thing.
Yeah, my aunt wasn't real thrilled. She didn't have any more after that one. She said, I'm done. So, okay, the thing here is, yes, one variable may cause a change in the other. May actually cause it. If you exercise, the number of minutes you exercise or the intensity of your exercise will cause your heart rate to go up. Okay? Up to a point. After a while, your heart will give out if you keep on going. Okay. Looking at these examples, let's see if we can figure out whether these correlations are positive or negative. Remember, positive means they both go up or they both go down. Negative means one goes up, the other one goes down. So they have opposite signs. Okay? At the beach, when more ice cream is sold, more people drown in the ocean. So you sold more ice cream and more people drown. Is it positive, negative? Well, they're selling more ice cream, so the amount of ice cream they sold increased. Yeah. And as the ice cream increased, more people drowned. So yeah, it's a positive relationship. It's not, you know, it's happening. I'm not asking you did one cause the other. It is a positive relationship.
So it's positive?
It is positive because one went up, the other one went up. Okay? Which explanation is the most likely? Coincidence, common underlying cause, or direct cause? Coincidence. It's totally coincidence. Automobile gas mileage decreases with tire pressure. When your tire pressure is low, you get lower gas mileage. When your tire pressure is high, you get higher gas mileage. So your mileage amount goes up. Your tire pressure should also be going up, right? Positive or negative? Well, this is where we got to think about how we would draw the graphs. So I'm going to take a little vacation here and go over to the side. Let me look back at the order that was there, because that makes a difference. Okay, the mileage decreases with tire pressure. So, tire pressure, yeah, just a second. So the graph would look like this. And it says mileage decreases, which means you're going to come down, as tire pressure decreases. Which way would we plot it? Basically, we're saying low tire pressure, low mileage, right? High tire pressure, higher mileage, up to here again, up to a point. Because if you put too much air in your tires, eventually it's going to blow and you're not going to go anywhere. Okay? So if you put the relationship that way, is that a positive or a negative relationship? Okay? So don't use the word decrease to tell you whether the relationship is positive or negative. Okay?
So it is a positive relationship?
Mm-hmm. Still trying to make sure my graph jives with what that says. It does, because as your pressure increases, your mileage increases, and as your pressure decreased, your mileage decreased. So when you're coming backwards, it would be that way.
So is it positive?
It is positive. In a large resort city, the crime rate increased as the number of taxi cabs increased.
Sorry, was that one a coincidence?
Oh, the tire pressure, no, the tire pressure, I forgot that part, thank you. There is a direct cause there, believe it or not. Your automobile mechanic would tell you this. If you don't have your tires inflated properly, it does affect your gas mileage. If your tire pressure is too low, you do lose gas mileage. And like I said, that doesn't mean you should go out and overinflate your tires, because that only works up to a point. It'll also wear your tires out if you overinflate them. So in a large resort city, the crime rate increased as the number of taxi cabs increased. More taxi cabs, more crime. Positive or negative? Positive. Because as one increased, the other one also increased. Remember, it's whether they increase together or they decrease together that tells you it's positive. If one goes up and the other one comes down, that's the negative. Okay? Now, crime rate and taxi cabs. Common underlying cause, coincidence, direct cause. I think you're probably right. What if I substituted in automobile accident rate?
Oh, that's.
Direct cause.
That's direct cause, because you have more taxi cabs, right? Now this one says, I'm sorry, I think I misspoke. This says the crime rate increased and the cabs, oh, okay, it also increased. I need to get my glasses checked. So yes, that's positive. Okay, in Angela's class, taller students got lower grades.
So was the city one a direct cause?
No. No, it was coincidence.
Okay.
If you substitute auto accident rate, that's different. Taller students get lower grades.
So it's negative.
It's a negative relationship. As you get taller, your test grade goes down, so it's negative. Is it coincidence, common underlying cause, or direct cause?
Well, if the test was a limbo contest, then there'd be direct correlation.
Yeah,
We need more context.
yeah, we need more context, that's a good idea. But in general, let's say it's Angela's biology class.
Yeah.
It's completely coincidence. Okay? And what we're gonna look at, I want you to get the handout about the calculator. Everybody hopefully has whatever calculator that you're going to use in front of you. You do this one time only, you never have to do this again. Once you turn the calculator on, clear off whatever you see on the screen, just hit the clear button. And I want you to hit the yellow or whatever color your second key is, the key at the top that says second. And then I want you to hit the 0 key. And it should say this. Second and 0. When you get to this screen, this is one-time deal. Second 0 to bring this up. Use your arrow keys to scroll down. And you'll see diagnostic off and diagnostic on. Diagnostic on comes second. Put that little triangle in front of diagnostic on. And hit enter 2 times. And that's all you should see. All you did was you turned something on in your calculator that might otherwise have been off. And you needed it to be on. Once you turn it on, it stays on until you turn it off. So don't turn it off. Leave it on. Next thing I want you to do is I want you to hit the stat button. The stat button is right below the delete button. You probably know where that one is. Okay? When you see that screen, I want you to hit enter because we're going to do something called edit the data. Now, if your next screen comes up and there are numbers in all the lists or there are no numbers in any of the lists, both of those are possible. Does anybody have numbers in any of the lists that they see on that screen?
Yes. Yes.
Okay. I'm going to show you the safe way that will not get you in trouble at 3 a.m. I'm going to give you the safe way to get rid of those numbers. You can't mess this one up. Get to your delete key and hit delete until they all disappear. However many times that takes. There is a way to make them all go away at once, but every time I show somebody that I get the panic message at 3 a.m. I broke my calculator. So they really didn't, but it just eliminates panic. So delete. Delete, delete, delete. If you have data out here in another list, just use your right arrow to move to the list and just sit there and hit delete, delete, delete until they're gone. Okay, so I want these lists need to be wiped out. I want you to go all the way across and make sure that for all 6 lists, you have no numbers in any list. Now we'll need to start with a blank slate. See, what happened is somebody had your calculator, and they did what I was telling you I wasn't gonna show you. So, let me put your list back. Because, I mean, eventually, if you, that mistake, I'm not gonna have any list. There you go. Anybody else need help getting the calculator to work right? Okay. Here's how this is going to work. We're going to type in data into list 1. The data we're going to use is the numbers 1, 2, 3, 4, 5. So I'm going to put my cursor in list 1, and I'm going to type in 1, 2, 3, 4, 5. And then you right arrow and you're in list 2. I want you to type in the numbers that are on your handout.
Mine are going like crossways instead of down.
You can't arrow down, but you can hit enter after each number. Yeah, okay. Okay, type in the numbers that are on your handout. We got 5.3, this is in list 2. Then enter. 4.5, then enter. 9.1, enter. 17.5, enter. And 18. Okay? Don't worry about what those numbers mean. It doesn't matter. We're just learning how to do something right now. So go to the next page on your handout. And what you want to do now is you want to hit your second button and your mode button to leave the lists. You want to get out of the list completely. Okay? And then you press your second and your Y equals button. Second and Y equals. Y equals is one of the blue buttons at the very top. Is everybody here? Yours may not look like mine, it's okay. It should look really similar, but you may have different pictures. Okay, when you get, this is called the stat plots menu. We're going to use plot 1 because it's already highlighted, so we're going to hit enter. We want to turn plot 1 on, so you hit enter on the on when it's flashing on the on, and it changes the black box over to the on. And then you want to down arrow and make sure that the plot you choose is that very first one right there, the one that's blinking. That's okay. After you hit enter, down arrow, and it'll go to the X list.
Sorry.
Um,
That's the one that's selected. Because it was, I had a gray X and that first brought it up.
you still want on the computer for the moment?
Okay.
And let me download this app.
Okay.
Make sure and let me look at what your app is.
Okay.
Okay, when you get to the X list, make sure it says L1. If it doesn't say L1, type your second and your number 1 key. And that'll make it say L1. If you look on my calculator, you can see why that works, because L1 is above the number 1 and it's in yellow. So I hit the yellow button, the number 1 key. Then I go down arrow again. And the second one should say L2. So if yours doesn't say L2, you hit second and the number 2 key. And make it say L2. And then you down arrow one more time. And then the mark, we're just going to leave everything as the default. So once you've set this up this time, you shouldn't need to ever change it. Once you've got it set up, it should be set up. And you'll always do the, just go ahead and do your plots because it'll already be set up to do your plot right. Did you figure it out?
I think I figured it out. It's the, you can select the, right there, and then I can change my,
Okay.
that's not y-axis, right?
Mhm.
X, Y, and that's the right,
It should be.
okay. Okay. I think that's, I changed it right there, to L1 to L2. I mean, I'm doing it on the computer too, but I don't know.
Yeah, I'm not familiar with that app. Mine doesn't look like that.
Okay.
Okay, at this point, we've set this up. Now we want to actually see the graph. So you hit your second. I'm sorry, not second. Don't hit second. Hit your zoom button. And you should see this. Don't hit second. Just hit zoom. Hit zoom again. Just zoom. Okay, you should see zoom in memory. Okay? I want you to scroll down until you see zoom stat. It's number 9. Scroll down to zoom stat and hit enter. There's your scatter plot. Okay? Does anybody not get a scatter plot that looks like that?
Mine doesn't have the box.
There's something here. There you go. The dots really don't matter, but It's just somebody who's looked at the way before. It doesn't have to have this on. Okay. Now, we're gonna practice some more next time with this, and,
So what's due?
3.4, whatever you have there, your notes are due. I don't think there's anything but notes. 3.5, keep playing with this to the point that we got. That's how you make a scatter plot. That's all you need to worry about doing right now.
With 3.4, there wasn't anything we wrote down, so there wasn't anything that we wrote down, so you just
Yeah.
did this one. So, like, there was nothing.
Yeah, you don't really have anything to do for that. So you get a little reprieve.
You want to finish setting this up or just leave it wait till next time?
Actually, it's already set up.
To have a,
If you want to follow through the rest of the handout, I'm trying to see.
no, like, do you have to have?
If you want to try to look through the rest of the handout, that would be fine, and then I'll go over it really quickly at the beginning.
So it won't be set up.
No.
But yeah, I was just there. Question. She made my
Okay.
life a few days after. What color are they? Somebody told me they may leave, so I couldn't see them today. 'Cause I did that the first time for some classes and they let me see them that same day.
Because when I did it,
It's-
when I
it's
did it,
probably
just
not gonna be-
save it as a PDF, it would split it. It was like half a graph was up here. I just, okay.
I'll just take screenshots, but mine would say nothing. Even
So
though
I
I'm
just took a
FlexDrive.
screenshot, put it in,
Yeah,
and
that's fine.
and it said it's everything.
Yeah,
So I
that's
did
fine.
it for 10, 11, 12, 13.
Yeah, I was gonna look over those tonight and make sure that they're all okay with you.
And this one, and on, another one, I didn't know how you wanted, is there anything that we need to write there? She said it wanted the frequency distribution, so I didn't know if you wanted this to convert it into a decimal number.
That is the frequency distribution.
Okay.
And you're gonna have to put it on the Excel chart to be able to make pie charts, so it's gonna be there.
Okay. That's what I thought.
She takes me on my own, what she's talking about.
I was just like, oh, there you go, thank you.
You have it marked out and switched. But then you have it something to.
That's why I didn't count off for it, because you got this answer, and I realized what you did. You did the reciprocal of it, subtracted it from one. When I realized that, I said, oh, she's got the right answer, she's got this.
I'm just like, did I do it wrong?
No, if I didn't count off points, I realized after I'd already understood what you were doing.
Okay.
Got to bring you some green, canned green beans.